All right. Hi, everyone. Thanks for tuning in today. And thanks to the flagship team for hosting. My name is David Thor. I'm the founder and CEO of Architect.io. And today I'm going to be talking about DevOps and more specifically, DevOps' role in improving developer velocity. Now, we work with a lot of different engineering teams via Architect to help them instrument DevOps and provide them our managed platform to do it automatically. But what I learned the first time I go into all of these orgs is that everyone has not just slightly, but a pretty wildly different definition of what DevOps is, what its roles and responsibilities are, and has a real trouble wrangling it beyond the namesake components of development and operations. So before we can talk about automating it at all, we really have to talk about what we're automating and give DevOps a firm definition. And to give you a glimpse as to how complicated this definition is, you can go straight to AWS's website and look up their definition of DevOps. This is literally the first line of that page quoted for you, which cites it as the combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications that are high velocity. Now, everyone wants a high velocity, but when we use the components, philosophies, practices, and tools all in conjunction, that's basically every business utility we have in our tool belt to make our business go. That really doesn't help us distill it down into what actionable responsibilities any single person or role should have. I'd say the only real glimpse you can get at what DevOps might mean from this definition is that it has to do with delivering applications and services, which is great. That's very important, and we'll get to that again in a second. But we really have to break it down further than that to gain an appreciation for it. Now, if you Googled DevOps and were looking for helpful visuals, I'm certain you would have found something that looks just like this. It's very natural to visualize DevOps as the intersection of roles, particularly of development and operations. And you likely would have seen it with something like QA thrown in there too. But you just as easily could have seen that thrown in with security via DevSecOps or product, because everyone really in the product fulfillment lifecycle has a vested stake in what DevOps is doing because it's a critical component of getting the code through and delivering it. And the rate at which we can do that is important to all stakeholders involved. So these are still too abstract to really act on. In a practical sense, what is DevOps and what can we do to automate it? And to do that, I'm going to break it down into the two namesake components, because that's really the easiest way to visualize it and gain an appreciation for its own definition, is to start with the components. And development being the first component, this is obviously a pillar of all of our organizations working in software engineering. Their first task, as always, is to ingest product features and designs and specifications, break that down into logical components that can be parallelized, that different teams can work on in parallel, and which components can we reuse? Do these components already exist? Can we consume them? Where do they live? And then for the custom code, we need to introduce what languages and frameworks need to be instrumented. Before, of course, we go and implement the feature, write that custom code, and finally merging that in with all the other code changes that all the other teams are working on parallel features. And this is, of course, via change control and version control. But the one definition I want you to take away from development is that development is responsible for the applications and code. That's going to be important, so put a pin in it for now, and we'll come back to it later. Now, on the operations side, this is where you'll hire your site reliability engineers, your production engineers. These are the people responsible for the last mile of serving the product back to the customers. And that includes a ton of responsibilities that have, like hardware fleet management, systems and network security patches, updates, and maintenance, database administration, where we have to figure out how to actually scale these large data sets and make them queryable from across the world. And then, of course, configuration and secret management. Not necessarily which applications need secrets, but the general practices for how we store and manage these secrets and how they get served back to applications. So the one definition for that I want you to put a pin in and save for later is that operations is responsible for infrastructure and environments. And this is going to be very important to our final definition of DevOps, so hold on to that for a minute. But before we can really give that definition, I have to remind everyone that organization relationships are inherently directional. And to give you that context, I'm going to add one more team here because it helps fulfill that full lifecycle vision, where product, of course, works to gain pains and understanding from customers before transforming that into application features and design. Development serves at the pleasure of product, making sure that those designs and those features can be transformed into code. And operations, of course, serves at the pleasure of development, making sure that code can actually be served back full circle to those customers. This is a directional relationship. The product does funnel in a directional way. And that's very important to our definition because it dictates that those two definitions are linear. One does transfer and translate to the other. And DevOps relationship sitting between development and operations is to turn those applications and that code into infrastructure and environments. Thus the two definitions that we had, and thus the importance of the directional relationship. And just to name a few, though this list does expand beyond this, your team is certainly doing a few more of these, maybe a few less if you're using managed service providers. Hopefully this is as easy a role as possible. But this includes roles like test enablement, making it so that the tests written by the development team or the QA team can actually be executed repeatedly and quickly, and the results served back fast and effectively so that people can act on them. Environment provisioning, which doesn't just include making production, it also involves making staging and sandbox environments, even private developer environments when it can't run on local hardware. And of course, application delivery too. This is the bread and butter of what DevOps was designed to do as per the definition before, where people need a method and path forward for getting their application from code all the way to infrastructure. And that's really where the deployment pipelines become important, both for the purposes of speed and the purposes of stability and safety, because the deploy lifecycle is where a lot of the most critical problems happen for applications. And then to name a few others, though these will get diminishingly important for the development use case, is database provisioning, making sure that developers have access to that habits as prescribed by those operators. Service discovery, which is the practice of finding and identifying peer services inside the same environment. Maybe I need the API service or the auth service or the payment service. Those need to be accessed. I need to know where they live and what addresses I can reach them at. Load balancing, which of course is the ability for us to scale this up, make multiple instances of each of these services, and make sure that new traffic hits the most available resources. Network security to make sure no bad actors can get into our cloud environment in malicious ways. And then, of course, like we noted for operators, is making sure the prescribed method for credential and configuration management applies to each service that needs those credentials. How can we issue those credentials, like a password for the database, and mount them to the applications? Like I said, your team will probably do more than this, but it gives you a better vision of what we actually expect DevOps to do and what all the steps are involved from getting code from developers and turning that into infrastructure. Now, operations has seen a ton of innovation in the last 2 decades. I'd say the first big one that you can point out to hands down is the introduction of public cloud providers that have made it easier than ever for operations teams to manage fleets of hardware, to make those available to users, to not have to manage the data centers in doing it, but also still getting all the perks, bells, and whistles of the security practices and tools that they've grown familiar with, maybe even been put in front of them for the first time because it's so readily available. But it doesn't necessarily help engineers or development access that infrastructure. That's really where the last 5 years or so has seen a much bigger boom with things like infrastructure as code. This has been a method for operations teams to package up common infrastructure elements into more bite-sized pieces, things that they can share with their team that they can understand a little bit more. That says, instead of these being the 25 different steps that you need to do to make and secure a database, here's the one step you need to do to ask for a database that includes all the security practices and postures as part of that flow. That's been a big wave of innovation for the operations team and has made DevOps a lot more happy in actually transforming that into infrastructure as code rather than bash scripting or custom utilities. Now, on the development side, while we've seen a ton of infrastructure operations and a ton of improvements in that landscape, really the only one of note that applies to infrastructure is containerization. This is really what got development involved in the infrastructure process in a tangible and developer-friendly way. They got to assert and package up all the information about how their custom code needs to run, from what operating system it needs to run on, to all the languages, frameworks, binaries, and other solutions that need to be included on that operating system, before finally including what the command is that needs to be executed to run it. All that in a nice, pretty container, go figure, and with a simple standardized run command that can be run anywhere, both locally and on your favorite cloud provider. But what's missing from containers and from that descriptive and declarative way that engages developers is a similar tactic for what lives outside the container. Nowhere do developers have a similar structured methodology that's standardized that lets them specify what databases that they need access to, whether or not they need access to the payments or the authentication service that these other teams have built, what notifications that I subscribe, what topics that I need from SNS or SQS, what queues I need. All these are resources that live outside the container that are important parts of the architecture of our applications that go undeclared. And what that means is that DevOps spends an enormous amount of time working with development teams to understand what that architecture is and transform that into infrastructure. That's really where our biggest manual bottlenecks exist for development and operations today. Now, even though that's where a lot of the DevOps engineers spend a lot of their time paired with these application teams to understand the application enough to transform it into infrastructure, that's really not a scalable solution. We already have centralized operations teams. We don't necessarily want to have to pair DevOps engineers with each and every product feature team. As a business scales, for example, they're going to want to invest heavily in new features. And if you have to invest equally heavily in DevOps to do that, it becomes a big cost factor that is a liability, not an asset. Those people are not working on product features for customers. They're working on enabling those features to get to production. And that really is what creates the need for big platform orgs and teams. And this is really that central pivot point where they are tasked with automating their own jobs, like most of software engineering, where instead of sitting alongside the developers, listening to what the application does and transforming it manually, they try to figure out the common patterns for the architecture and expose those as declarative hooks, much like the Docker file allows you to do that for your container, or infrastructure as code like lets you do that for infrastructure. DevOps further builds a layer that makes it easier for developers to assert things like, I need a database, I need an SNS topic, I need a bucket to put my data into. All these things are claims that the developer makes, and the platform orgs are responsible for transforming those claims into infrastructure automatically, not via manual practices, but with tools and technology that can grab and scrape it automatically and execute it. This has really becomes a necessity for the bigger orgs in order to scale. And what you may notice if you talk to a lot of these teams is that what they've built shares a ton in common with each other. And the way it gets served to developers is similar too, but that lacks a name. So I'm going to name it now, actually. And I'm going to name it architecture as code. Because really that's what it's trying to do. The platform orgs are trying to make it easier for developers to engage with infrastructure and then to automate that relationship. But to do that, those DevOps teams have to understand what it is the application is doing and what the relationship is between the different containers and entities. And that really amounts to architecture, network architecture, microservices architecture, event-driven architecture. It's all that has to do with the stuff outside the container, and developers just need to declare it. So those platform teams all end up building architecture as code frameworks that funnel through their platform and transform it into infrastructure. And that's really what powers a lot of these innovations and a lot of these larger orgs to scale and adopt new tactics and services at a rapid rate. That's really what cloud native is quickly becoming, is this set of tools and services designed for developers in a first-class setting to actually engage with infrastructure. So just to give you a little lens into what this looks like and how we came to this conclusion is we started off with the assertion that infrastructure as code brokers the relationship between DevOps and operations. And I just said that this new term I gave you, architecture as code, brokers the relationship between developers and DevOps. Now, naturally, through that transformation funnel, the conclusion was that architecture brokers the relationship between developers and operations. Now, DevOps is responsible for building that platform team, or if you call it, that platform team is responsible for building the platform itself that does this transformation. Much of this transformation amounts to taking architecture as code and turning it into infrastructure as code. But nonetheless, the tools are there. The power to automate it is there, and the platform teams are already on the path to doing that. And what they all end up building is something that looks and feels and is shaped the same. So DevOps can be automated. We don't call it DevOps anymore. When you do that, we call it platform. And that's something that benefits every business to have, but takes an enormous amount of investment to do up front. But I'm a big proponent of it. I'd encourage a lot of teams to do it. It's certainly my recommendation to invest in a team to do that instead of DevOps engineers paired with every team in org. It's way more scalable and allows developers to serve themselves, gives them the power to really drive the product in ways that they couldn't before. And obviously that's my philosophy. We're building that at architect.io too, trying to make that readily available for others. So if anyone has any questions, please feel free to ask. I believe there's a Slack group open after this, so I'm happy to field questions as well. So thanks everyone, and hope to talk to you soon.